Hi, Dr. Revis here with Watch Me Work It. Expand octet Lewis structures having lone pairs and multiple bonds. So, watch me work it. We will draw Lewis structures based on the following formulas, and we will use the rules shown here. We will pay special attention to the expand octet rules. For more on how to apply these rules to Lewis structures, see my other videos. So let's get started drawing these, assuming you have a general knowledge of what Lewis structures are all about. We'll start with sulfur. It's located in group 16 or 6A, therefore we'll have 6 valence electrons. We would draw these using a circular motion around, assuming 4 sides, and this is what our initial structure for sulfur will look like. We would now draw chlorine using a similar process with 7. We go around, and that's our initial structure. So we'll get the same thing here. Just for discipline, I tend to keep following the same pattern. So here, Cl, 1, 2, 3, 4, 5, 6, 7. Make this a little darker. And I'm just going to put the other one right here. 1, 2, 3, 4, 5, 6, 7. Once I draw this, I know it puts sulfur as a central atom because it has the highest number of unpaired electrons. So what I do is I connect the obvious dots here. The single dots are ready to bond. They're hybridized. They're plus spin up. So I'm just going to go ahead and connect these right away. Only the single dots. And then what I observed is that I don't have any leftover single dots for sulfur to bond with. So I must split a lone pair. That's called hybridizing it. So we hybridize that. That means now it's spin up and can bond here and can bond here. And therefore I get my initial structure of S, Cl, 1, 2, 3, 4. Put these back. This is simply copying. And I'm going to put this chlorine over here. And I'm going to copy these electrons here. I'm going to put my other chlorine here, and this is going to copy here. So I copy there, then I put this chlorine, and I copy these electrons here. And then I observe that I have a leftover lone pair, and I'm going to put it right back in here. And that's the expanded look for SCO4. Let's take a look at SO3. So we're going to redraw sulfur here. And we'll have 1, 2, 3, 4, 5, 6 electrons. 2 are available for initial bonding. Let's do oxygen. 1, 2, 3, 4, 5, 6. That's oxygen with 2 available for bonding. I'm going to put the other one over here. 1, 2, 3, 4, 5, 6. And then let's stick the other one right here. Just give us a little space. 3, 4, 5, 6. Now, as I observe this, all of these want to bond twice. That makes it a little challenging. And there are only 2 electrons on the sulfur. So you know what I'm going to do? I'm going to go ahead and draw my messy lines and take care of those 2 right away. As soon as I see that, that means I have 2 left over. That means I have to promote this set of electrons. That means split them. So when we split them, this is going to go here. These are my messy lines. And these are going to go here. And I still have 1 left over 2. So I'm going to split this last one. And this really gets kind of messy here, but I think you get the point. We're going to take this one right up here and this one right here. Then I'm going to just clean my lines up and make this look a little neater. And since these molecules like to have nice, neat spacing, I'm going to space them out. And I'm going to leave these electrons on the side because that's originally where they were in my originally drawn structure. And I get this. The key here is to take care of the initial bondings first, and then hybridize, split the lone pairs as needed when you're doing expanded octet. Let's do 2 others here. Let's do NeBr2. So that's neon. That's going to really max out this electron octet, isn't it? So we have 8 here. That should be neon. Let's redraw that. And we have Br2. I'm just going to put 1 Br right here. 1, 2, 3, 4, 5, 6, 7. And I'm just going to put the other one right here. And this is going to be 1, 2, 3, 4, 5, 6, 7. And I have no initial bonding opportunities on neon. Therefore, I must promote some electrons. And so I'm going to promote this set of electrons. That means I'm going to split them. So they've been promoted. Now they hybridize for hybridized bonding. And therefore, we attach the 2 borons there. And just for spatial reasons, I'm going to spread these out a little bit. It's 2 of them. So I don't know exactly where they're going to be. They know better than I do, but I'm just going to put them right here. And we redraw the leftover electrons here. Hopefully you can see that. That's getting a little close to the other place there, but I think you understand what I'm drawing. And we have the bromine here. 1, 2, 3, 4, 5, 6. And then we have these leftover lone pairs. Sorry for the messy look. There we go. And we have 1, 2, 3, 4. 1 set of lone pair, 2 set, 3 sets of lone pair. It's going to look something like that. Okay. All right. So now let's do it in O4. So we have neon in 1, 2, 3, 4, 5, 6, 7, 8. I did it again. Neon here. And so we're going to have 4 oxygens. I'm just going to put them right here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And one more time. 1, 2, 3, 4, 5, 6. And neon has no initial opportunities to bond. Okay, there are no hybridized electrons there. It looked like I added an extra electron right here. There, I got rid of it. All right, and so that means we have to hybridize, split, promote these electrons. So I'm just going to go ahead and promote these 2 at the top first, and let this one come over and bond here. These are what I call my messy lines and bond here. Then I'm going to promote the ones on the side. This is going to come over here and bond. A little messy, but just to show you where all the connections happen. Let's promote these, and you do this one at a time. Makes for a lot easier to see where things belong. Then promote these next. Every time you need new bondings and they're already lone pairs, you have to promote them. Really messy here, but just to show you the point. So now we have neon, and this is a double bond there, and that oxygen has 2 lone pairs left over. On the right side, there's another double bond here. And someone's asking, why couldn't you just see it at the beginning and do the beginning? Maybe you could have, but I wanted to emphasize the need to recognize splitting lone pairs to expand octets. And therefore we split these, and we have the expanded octet here, and we have the expanded octet again of neon with 4 oxygens around it, and we have expanded octet of neon with 2 bromines around it and 3 lone pairs. Case of neon with the 4 oxygen has no lone pairs left. All right.